Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. We are at episode 60, which I called Libretro Impl, short for implementation, part 1. Couple reasons. First of all, I know it's going to be part 1 because I think we're going to be working on this for a couple weeks. I'm basically not working on this project outside of the streams right now. And there's a lot of stuff I want to do, so I think this will take up some time in the next few weeks as well, which I think will be cool. Kind of a lot of stuff we have to cover doing a proper implementation for Libretro. Some somewhat interesting refactors that should actually make things quite a bit faster that I'm thinking of, and some other stuff. By the way, I think I mentioned this, I probably brought this up in a couple other streams. I don't know how much of this I showed, but this is actually Retro Boy running in RetroArch. So a lot of this work is already done. I don't know how many times I've talked about this, but Sebert is a guy that I work with, one of my colleagues, who did sort of the initial implementation of this. It was actually his first Rust project, which was really, really cool, and did a lot of this work about a year ago, actually, just kind of getting things working on a basic level. Then I took that over a couple weeks ago. Must have been 2 weeks ago that we just started looking at this. I think it was the one year Retro Boy episode. Right after that, I just kind of took a look, especially that weekend, and really sort of got my head around it, and understood the API a little better and what it expected, and then started refactoring the code, running Rust format on it, moving a bunch of things around. I'm not done with that. There's a lot more cleanup that I think needs to be done, but before I get too much farther with that, I'd kind of like to talk about what has been done so far and more or less how this API works. Not as in like this is a tutorial or great introduction to Libretro, but at least to show how sort of the concepts map and some of the basics in order to set up the stage properly to look at what we're doing. Additionally, I just made this huge list at the end of that weekend, actually, where I just kind of brain dumped all the stuff that I thought was missing. And here's a lot of it. So just going to be banging stuff out, like pixel formats is one thing that I want to look into fixing first of all. But yeah, generally it's not too bad. Here's something that's pretty nice. When I move around the window, it pauses and then it unpauses instead of just keeps making noise. That's kind of funny with the CLI implementation. I can pause and unpause. I can actually go to full screen, which will probably cause errors with my streaming stuff. Let's find out. Yeah, no idea if that worked for you guys, but can do that stuff. It's pretty cool. I actually have controller support with this now too. And we can look at things like taking a screenshot, which I can just do. And then I can go up here in my menu and we can see the screenshot there. So it's actually pretty cool. Lots of other things. Even change driver for stuff. Really, really cool. So yeah, so a lot of progress on this has been made. And I just want to keep working on this, basically. It's what my plan is for the stream. So just going to start banging some more of this stuff out. By the way, howdy guys in the chat. Zokwar, SK Thes, Dark Second, and Skeleton. Yeah, it was worth a shot, but I guess the full screen thing didn't work. Michael McMillan, this is Sublime. Also, hi. Sorry to hear that you've been ill, Dark Second. I was actually out of work yesterday, too, due to being ill. For about a day and a half. Another thing that's been going around the office, and I spent some time last weekend with a couple people that had it, so not that surprised that I had to take a day off. It might be part 1 of 100. I doubt it. But it is something we'll probably visit for a while, and then I might go back and optimize some stuff for a while and then come back. But who knows? Might be that stuff just takes forever. Mike McMillan, hadn't realized. I mean, I get that question so often now that I'm just kind of used to answering it. That's funny. Libretro, the basics of it are not actually that tough, which really helps here. I can actually just show you how this works, just as kind of a like super rough introduction of how this works. Again, the code's not the cleanest, and there's a lot of this stuff that'll change, but I want to go down here. By the way, all this is public on the Rustro Boy repo under the Libretro branch. But the idea is that you basically just have to implement a certain C API that has all these entry points. So there's retro API version, which will return a given API version to make sure that the host's API that it implements matches the API that the core expects. Because that's what this basically is that the idea is that the Libretro API is sort of a boundary between the cores, which are like emulated systems or really anything that implements the API, and so they sort of act like the emulator. And then you have the host, which will actually run the emulator inside of it and also hook it up with a bunch of other drivers to hook it up to audio and video and all that stuff. So the API is basically as follows. You have a retro API version. Excuse me. That just a regular C function that returns a U32. Jeez. Sorry about that. I don't know what's going on in there. And after you do that and everything matches, then it will actually start loading the core more properly. The core itself, by the way, it's just a shared library that implements this API. That's all this is. So you have retro init and retro dinit, and these will initialize and deinitialize global state. Now, in the original docs, it actually says that it first will call this, and then it will call retro init, so you can initialize some global stuff. It actually doesn't. In at least RetroArch, which is kind of like the de facto implementation of Libretro host, before it calls these, it actually starts calling these set callbacks. And what it will do is it will send the core a bunch of callback functions that the core can use to update the host. So the idea is that this one, this video refresh callback is the one you're supposed to call when the emulator produces a new video frame. And then here's the one where it produces a new audio sample, or you could use this audio sample batch, which is where you produce multiple samples. This is the one you call back into the host to have it pull the input. I don't actually remember the difference between input pull and input state. I'm sure we'll see that as we get into how these are implemented. And then there's this environment, which is sort of a generic callback that you give it, a certain code for something that you're trying to ask of the environment, and it will return whatever data that you asked for. And so it sets all these callbacks first, and then eventually we'll call retro init. So as a consequence, we actually have two different pieces of global state. And to do that, I just have these two static bits here, callbacks and context. So it's basically as you would do in C, which requires unsafe code, but I don't really care about having unsafe code on the boundary because we are implementing a C API that is going to assume some things that would normally be considered unsafe in Rust. So instead of trying to clever my way around that, I've just kind of just done it as is. And the callbacks, again, are set before we get any of this init or dinit. So we kind of just have to have that available. Now, on the context, I do actually have this through a pointer here that initially is null. And then on init, I actually create a new context object, which will contain a bunch of our emulator state beyond that. And then on dinit, then I can just drop that. So it's not too bad. Skeleton, no plans on my end. Someone else has worked on that. But it didn't seem very mature. And it just didn't seem like I would get much from using it. So we just kind of did this by ourselves because it's not that bad. I mean, it's very C-like, but that's it. So just implementing it is really not that bad. So yeah, I don't have plans to do that, but I think there is a crate that exists for doing that. I don't know what this set controller port device is. We don't need it, and there's a lot of these that I just have exposed because the host had called that at one point. So even if we don't implement it, just having it available on the API keeps the host from crashing. SKThess, I would not change anything of the architecture. In fact, one of the reasons I did talk about the audio stuff and that architecture is the fact that it held up through that. I will change the implementation of our syncs because I will have them actually contain pointers to buffers that will persist between frames in order to make that faster. But other than that, the architecture will stay exactly the same. So it's pretty good. Yeah, and then we also have get system info. This is also called before retro init, and this will create a new system info struct. The idea there is that just tells it things like library name, library version, extensions, and stuff like that. Just things about the host itself. About the core itself. And then we end up getting retro init, which sets up some of our global state. And then if the core was provided with a game or a content, as it's called in Libretro, then we get retro load game, which will give us a game info struct, and then we actually read that. And so that in this case has the path, the actual data, the size, and then some whatever metadata. And in fact, you can actually, I think it's in system info, you list whether or not your core actually needs a game or not to run. In this case, ours does. You can't like start a Virtual Boy without a cartridge inserted, at least not for proper operation. So we just disallow that. And then the host will actually not start your core if it doesn't have content. In fact, if I do this just on the command line, if I don't specify a ROM, the host will actually crash, or it will show us an error that failed to load the content, and then it says this core requires a content file. So don't really have to worry too much about that. Hey, Metal Voids. So not too bad. So that's load game. It also has like get system AV info. This is another one that can be, I think this one can't be called before that, or at least it isn't, which is why we just deref the context and look at that. System AV info gives us stuff about like the width and height of the frame buffers, basically the output, and also the sample rate, which is pretty cool. And then, yeah, so eventually we can get unload game and then load game. So if we loaded a different game in the core, for example, that would happen. Reset is another thing we can do. That one is implemented, I'm pretty sure. So I can do like command reset. And that's it. So that's pretty good. And then retro run is called, I think, every frame. It's just based on what I have here that it calls a run frame function on our context. We also have get region. One is actually PAL. I put to do here because it doesn't really have a region. Like that doesn't necessarily match, but the host does call this, so we implement it. There's also get memory data, get memory size, and this I think is for save RAM, which we haven't implemented yet. And then we also have serialize size, serialize, and unserialize. And these are for serialization for save states. Then there's stuff for cheats, which is also not implemented. Oh, 8 little bits. Thank you so much for the subscription. Really appreciate that. Hey, Pyro ESP. Yeah, thank you so much, guys. So yeah, so that's the whole API surface that we've implemented. There is a libretro.h file here. I can go ahead and link that, although there's a specific line of it that I've linked here. But here, there's that, and this is just a header that is like basically the entire API. You kind of have to look at this, some documentation they have, and then some of the RetroArch implementation to really do this properly. Oh, thanks also Skeleton for the for the sub. Really appreciate that. Oh, that's funny. I didn't either, Skeleton. I didn't realize you had to renew those either. But thank you. Yeah, I thought you had subbed before. Both of you guys. But anyway, thank you again. But yeah, there's stuff about achievements, network play, all that kind of stuff that right now we're just not really looking into yet. In fact, I think also here, I don't think I put save RAM in here. So I'm just going to add that to this list. I've been asked previously why I do these tickets with big lists like this rather than like a milestone and many tickets. And honestly, it just helps me to be more organized to see the overview. That's all it is. It does have a downside, though. If more than one people check off those boxes, it doesn't sync the state very well. If multiple people like have that page open in a tab and one of them clicks it, then the text won't update for the other person. So that's actually really bad because then like another one can click another box and then that will end up being the new state because it really just overwrites the text. So yeah. Yeah, VB does have save RAM. In fact, this game in particular should have, well, it shouldn't actually show this, the different saves that I have in this game because they're not being loaded or restored right now, or loaded and saved. And thanks, Michael McMillan, for the sub. And sub party over here. Sub Central. I love it. But yeah, Virtual Boy does have save RAM, but I haven't implemented that for the Libretro core, so that's not going to be set up here. But generally, the implementation of these is actually really straightforward. I have a context object, which is sort of the global state object. Now, again, the only thing that's really distinct from is the callbacks, and that's only because the host will actually set these before it gives us a chance to create the context. If we were using non-stable Rust, we could actually have the context object be created here and not go through a pointer, but because destructors in static objects are actually an experimental feature, that won't work on stable Rust. So instead we use a pointer here that then we create here and then delete here and just have the callbacks on a separate struct, which is fine here because we don't need destructors. That's why it's okay here and not for the context. Is not working. Oh, it should totally work. If they're 3D anaglyph classes, they will totally work. I mean, there's no explicit support for it, but if it's the red and cyan, then it should be correct. Sometimes you'll see me just start the emulator a bunch of times, and let me explain what that is. This is kind of an issue. It's an issue with RetroArch, let me be clear. So one of the things that when this starts up, it's somewhere as it's bringing up the emulator, there's a function that you can call. It's one of the callbacks, which is, I think it's one of the environment callbacks. But you basically, your core sets the desired pixel format and basically sets the pixel format that's going to be used by your emulator to output pixel data. It mentions that you should only call that, I think, when it's getting the system AV info or when a game's being loaded. And we call it when a game's being loaded because that's when the Libretro examples do it. Anyway, here we call set pixel format. And we set this pixel format. And it seems, I wrote a note here about it, it seems a lot of the time the Libretro core doesn't ever seem to see that call. And sometimes it does, and then it works as expected. And if we look at the log, I'm running this verbose, then we can see somewhere here that set pixel format sets it to our pixel format, and then everything works fine. When it doesn't work, like now, that's nowhere to be found in the log. So it seems like that call just didn't get through or something. I honestly suspect, because I know that they added multi-threading to RetroArch recently, I actually think that it's setting up the video on a different thread and it just misses the call. I haven't looked at that yet. I did speak with some of the guys in the Libretro Discord, and they were, of course, very friendly, but they did seem to say that that was weird. And one of them suggested that I look into it with Memory Doctor, or Dr. Memory, and I haven't done that yet. I would like to do that, but I haven't gotten around to doing that yet. So right now, I just kind of ignore this. Because here's the thing. When you call this, there's no way to actually get what pixel format the host is expecting. Because what's happening here is that the host is expecting the default pixel format because it didn't seem to notice that we called this. But since we're outputting in this pixel format, there's misalignment. And so in particular, the pixel format that it expects... Another sub. Thanks, Metal Voids. That's so funny. I love it, guys. But yeah, so the idea is that the default pixel format is, I think, 565. It's a 16-bit format, so that's why things just get super stretched, because it expects it in that format, and then we give it to it in 32-bit pixels. And again, because we expect it to do this, and the host doesn't expect that, then things get messed up. And there's no way to ask the host what pixel format it expects. That's kind of the issue, unless we use a different output code path that actually has the host allocate the target frame buffer and then send that in, then it will also tell us what format it expects the pixel data to be in. And that's actually something we should consider doing. And I have some refactoring ideas that could support that, because that'll be faster. Right now, we actually do already have our own buffer that we maintain here in order to make that faster. But there's some extra copies that actually take that out of the pixel data and then put it in there. And then I expect the host would do another copy, even though it seems to also persist a pointer to this buffer, which is actually why I keep it on as part of the global state. And I'm not really sure why that is, but yeah. Skeleton, I did also try it on the AV callback. That's when it didn't work. And then I talked to the guys in the Libretro Discord, and they were saying that you shouldn't have to do that. Do what the samples do, and the samples only call it in run frame, load game. And then after that didn't work, that's when they suggested I look at it in Dr. Memory. Dr. Memory is apparently like Volgrind, but on Windows. I haven't used it, which is why I haven't looked into that, but I will try. But yeah, they very much recommended that I don't do it on both, and they think it's a problem with Libretro, and I'm happy to debug that since I have here somewhat robust reproduction case. But yeah, so at some point I'll look into fixing that, but I don't want to do that on my stream. So I'm not gonna right now. So what I might do today though, is just use the default format, because that should work, even though the default format's actually deprecated, which is another thing that's just kind of sucky about the situation. But if that's one way to contribute, it's still kind of worth doing that, I think, considering it's still a shorter path to getting a nice front end than doing our own. So nice, Ion Codes. Welcome back. But yeah, so that's where we're at. And then a lot of the implementations of these, all they do is they just take this context object, dereference the pointer, assume that it's valid, which it should be for the lifetime of this. And I don't want to do a bunch of extra conditionals for every single one of these API calls that checks that, because if the host is worth anything, then it should be correct. So I'm just not that worried about it. Grumblix, thanks for the sub. Man, sub party today. Oh, awesome is not working. I'm super happy to hear that. That's so cool. I love it. But yeah, so all these just deref the context, and then just call the equivalent function on the context object, and that allows me to again just have the context struct here. And there's a lot of structs here that are just floating in this lib.rs right now while I kind of figure out how the optimal data paths, and then I want to separate those out. But for now, it just is easier for me to keep them all in one place. I think so too. Is not working. I actually really like how the Virtual Boy looks now after having done all this. The 3D effect is actually surprisingly convincing. But yeah, so like that load game one, we'll just deref the context and then call this one here. The object itself, it has a system, which it's just the Virtual Boy struct itself, and then the information about how long stuff has been emulated. If you guys saw my last episode about talking about the general architecture, and especially timing and audio, these should look familiar. This is how many cycles the emulator has been emulated or has emulated, and then this is the amount of cycles it should have. So sometimes this will be greater than this. But yeah, so like one thing that's different is that the CLI version of Virtual Boy will just sort of run in an inner loop, and then whenever the emulator puts out new audio or graphics data, we just pull that out. In this case, Libretro expects that you run one video frame. It gives you a call function that it calls, and it expects you to run a whole video frame. And in that case, well, we know exactly how long a video frame is. It's exactly this long, which is 1 second divided by 50 frames a second divided by 50 nanoseconds per cycle, and then we have the emulated cycle. So we add that many cycles to whatever our target emulated cycle should be, and then while the system hasn't done that many cycles, then we're just going to step the emulator. So it's really quite basic how that works. It's the same stepping code that's in the main loop of the CLI version of Retro Boy, but it's just what it uses as a time source is, again, a little bit different. And then it pulls the stuff out of the sinks. The main refactoring that I think I want to do to make this stuff a little faster, by the way, is instead of having the sinks actually temporarily store the data, I think I'm going to refactor the sinks to store references to output buffers. That would allow us to, for example, just retain the buffers the whole time and not do any allocations, and potentially make some of that a little bit faster. It's kind of at the expense, though, of a little bit of flexibility, because then suddenly the emulator needs to output in the right format. And for example, if we want to support different output pixel formats, the emulator kind of needs to be aware of those now. And I think that's actually fine. I thought a lot about that, and I kind of didn't like that at first. I thought it was a little more elegant not to do that. But I think that, we go through enough data that would actually really help in terms of speed to not allocate so many buffers and not pass so many buffers around. So I think that should be fine. Dark Second, does Libretro have support for anaglyph video? Libretro doesn't explicitly, as far as I know. You just output pixels into a buffer, but there are different Libretro implementations in terms of host implementations that will expect different output formats, and for stuff like VR. That means we actually in the core have to support those specifically, and that's something I really want to look into, but haven't looked into that very much. There was also one of the Libretro guys, B. Parker, I think was his handle, that was talking a lot about, he had professional experience in ways that you could take stereo video and then turn it into some kind of output format to either work with a particular stereo display or 3D glasses or whatever. He had a lot of experience with that, it seemed, professionally, so he had a lot of ideas on how that could be done for a core. So at one point, I would like to talk with him again, just enumerate a lot of different ways to do that. Again, all of those are going to have to be supported in the video emulation of the Virtual Boy right now, but I think that's going to be okay. The way that I've architected that part of the code, it doesn't hurt us too much to have it that way, because I think it's this display function here, gets the brightness and stuff, and then basically just pulls the graphics out of the frame buffers and then puts them into these buffer pointers. So it actually isn't that bad, because basically this stuff is the only stuff that changes. So there'll be a few different specializations of this, and I'm not that worried about that. It is kind of annoying to have it here, but I'm also thinking that if we, because right now the sinks, we have just a sink of T, and then you have a append here. Whoops. But I'm thinking a sink will actually, it might be a buffer instead. And then instead of, pushing a value where you give it a new value that it owns that, for example, like we would actually give it a vector that owns the pixels, this will actually have a reference to a particular kind of buffer on it that then you write to. So yeah, I'm using raw pointers for some speed here. That's why this is unsafe. There's a few places in the emulator that we do that, and it is a lot faster, actually. But when I do some refactorings, I want to do some more profiling eventually and see if it still makes that much of a difference. But it definitely did when I put that in there. Otherwise, I wouldn't have done it. I do it there, and I do it in the ROM and the SRAM, because there's a lot of checks, like when you read bytes and stuff, where it masks the address first. And also when you create it, it only allows you to do ones that are valid sizes. So we get a lot of checks, invariants checked there. So then by the time we actually do that, it doesn't really matter. The only downside is that I had to do my own implementation of clone for both of these, and that was it. So it's not too bad. See you later, skeleton. So that's basically where we're at. But this first thing I want to fix actually is just supporting this default data format. Now, again, it's may not be the easiest thing to do just because that actually touches the sinks already, so we have to refactor the sinks, but I think that's okay. Do we actually use this sync ref thing? I don't think we do. Maybe we do. I don't think so, though. Oh, yeah. Another thing I want to refactor pretty quick here is there's two ways you can do output on Libretro. It gives you two different callbacks, audio sample and audio sample batch. The idea is that audio sample, actually, well, let me look at I think I have a thing here for just the callbacks. Yeah, so audio sample, you call that for every audio sample that your emulator produces. Currently, we use this because it's simpler. In fact, I believe that the audio output callback sync here, every time you call append, it just calls append on the host. So it's really easy to implement here. But if your emulator can, you should actually rather use this, which is where you give it a buffer of samples and then the size of that buffer. And this way you can just do one call to the host, because these are basically all virtual calls since you're going through a function pointer. So you need to, yeah, so this would be a lot faster is basically the idea. Not super important, but there's a lot of these paths that I want to just make as optimal as we can, because if we're doing a lot of data copies, that's just kind of crap since we know where they're all going. So that's something I'd like to fix. Got a lot of things on my list, but I think I'll just start working on these. Actually, the way I'll do this at first, I think, let me look up what that was, that default audio format. If we just search pixel format. Yeah, so it's this 16-bit format that's the default. It's basically just 5 bits per component. That's actually totally fine for us to use, because the Virtual Boy itself is only really doing 2 bits per pixel anyway. We're only using 2 of those components. And we do some gamma correction stuff since this is usually going out to a screen. And so this is not at all a problem in terms of the amount of precision that we actually need. It's just that this is the format we already have, so that's why I went with that first. But this does set this pixel format is default for compatibility concerns only. If a 16-bit pixel format is desired, consider using RGB 565. However, until that Libretro bug is fixed, or RetroArch bug is fixed, I'm just going to assume that this is the default for now. So we'll support this. Now, doing that shouldn't actually be too hard here. Let's see, what was I going to do? I'll just do this. First of all, we're not going to do the call that sets the pixel format. And so now it's always going to be broken. But that's fine. We expect that. So now the easiest way to do this without going through the entire stack is just to do this on the end. So here, I think I have a video callback sync up here. Yeah, which whenever it gets a new frame, it goes through and it outputs that pixel data into the output buffer and then gives that to the callback. So it's doing basically an extra data copy here, which is not ideal, but it's fine. So actually, wait a minute. We have color frame, which I think is on, it's either in syncs. No, that's not there. It's in our middleware crates. We have color frame here. It's just a box of color. And then on into, we can do into U32, and then it just outputs that, for example. Now what we want to do here, the easiest way to do this is just to do a couple things here. What I'm going to do is, let's see. I want to take our output buffer here, which right now is a vec of U32. So I'm going to make that U16. And then, yeah, so now into here, we don't have that implemented for U16, which is fine. That's ideally what would have happened. So now I want to implement that here. So we can do into U32, and we can also do into U16. Now, the issue with this is there's actually two valid 16-bit color formats, basically 555 and 565. If you guys have never seen that before, by the way, it's actually because if you have 16 bits to use for a color, which of course is pretty sensible because it's, you know, it's half the size for your frame buffer and half the bandwidth to actually process such a frame buffer, to either move it or do some kind of operation on it. It actually, like 555 is most convenient because you get 5 bits per component. But since you're going to be spending 16 bits anyway, it kind of makes sense to try and use that last bit. So it's often given to the green channel because I guess the human eye is actually more sensitive to changes in green than it is to red and blue. So that's why it's often 565. The issue here is that just going into U16 isn't very descriptive. I may actually get rid of this color stuff that we have right now. But for now, we'll just make this one be this particular format. So this actually shouldn't be too hard to do because originally these are 8-bit values. So if you just take the shift right 3, then we should get 5-bit values. Very, very easy. The other thing we need to do is instead of shifting this 16 and 8, we need to do 10 and 5. And that should just work, I think. No, because I don't think we changed the format in some other place. Where was that actually? 203. That's down here. I think it creates the buffer initially. Oh no, video callback sync here. Right, because we changed it on. What do we do here? Yeah, we changed it here on the sync, and then we didn't change it on the system, or on the context, that is. U16. There we go. So now this should work. Now, one place where this does actually kind of suck is the Virtual Boy. So it has 2 bits per pixel, so really only 4 different color choices. But it also has different brightness values, different brightness settings, which will control how long the LED is turned on. So we do actually lose a bit of color depth here. Now that I think about it, now that I saw things fading in, I did see it flickering more than I thought. But it's because, you know, when it fades in, yeah, it is actually usually using those, like changing the LED brightness registers. So, and those are normally analog. Those are normally continuous, although it is a digital amount for how long they could be turned on or off. So, but this is fine. So that's kind of a quick fix for the issue, though. There's still the deeper refactorings that I want to do that make this a little bit nicer. Like, right now it kind of sucks that we produce 2 buffers with at least 24-bit color, although I think they're 32-bit just to make the storage easier. Maybe they're both 8-bit. That would actually make more sense. So I think we produce 2 8-bit buffers. In fact, I can check that because the syncs thing here should have a video frame that is box U8 U8. Yeah, so we produce 2 8-bit side-by-side stereo buffers. And then the way that our syncs are implemented, So we have it, we actually allocate new buffers and then have the video hardware output those, and then we stuff those into this video frame struct, and that gets put through a couple things. It gets put into these sinks. That goes through, I think we do gamma adjustment before that. No, not yet. We do anaglyph first. Or do we? Okay, yeah, so we do this in this most recent sync first. So we put this in a sync here that just hangs on to the most recent one. If a new one comes after this, it'll just overwrite that. After that, I think that gets put through this anaglyphizer, which, yeah, takes in a video frame and then outputs a color frame. And so this is going to take the two side-by-side buffers and then put them into one buffer, which is 32 bits. That's what the color frame thing is. Then that gets gamma adjusted because that's the output of that is going to be displayed on a computer screen. Otherwise, we wouldn't do that. And then finally, that is the thing that actually gets output. And each one of these, I think, does their own buffer allocation and data copy every frame, which kind of sucks. In fact, I think the gamma adjust one will even figure out its new gamma table every frame. It's pretty wasteful, but it was a nice pattern to use, at least at first. Which is kind of why we did it that way. But now I'm thinking that I don't want to do that anymore. Because it would go through that whole pipeline, and then at the end of that, now, what we've just added, it would normally do another buffer copy. Now it does a copy and a color conversion to 16-bit. Now that should actually still net be faster, just because it's producing a quarter. It's going through a quarter of the data. Sorry, half the data. So even though there's more ALU going on, I don't think it's enough more to offset the amount of data that we're actually moving here. So it does another copy, and then it gives this buffer to the host, which again does. That's probably another copy. There is an output code path. I think I mentioned this earlier, where you can have the host actually allocate the memory for output, and then just pass that to the core every time it needs to render a new frame. And so if we could do that and then wrap that in a sync and send the sync all the way down to the actual video hardware emulator, and then have it output directly to that sync, whatever that format is in, then we would actually avoid all of these copies. The downside of that, and the reason why we didn't do that in the first place, is because right now it's kind of elegant that the video hardware doesn't really care about output formats. It knows that it produces two output frame buffers, and it just does that. And then we do all of the other color conversion stuff outside of that context, which I would much rather do. But I don't think we can ignore the potential savings we'd actually get from doing this a little more properly in terms of speed. And I don't think it hurts the elegance that much. It just kind of moves some of this Rusto Boy middleware stuff into the core, which is really not the worst thing to happen to that anyway. And I think a lot of this middleware stuff actually goes away if we do that. It's a design I used to like, but now I'm liking it less now that I'm plugging it into more things. Because we still, like, how am I thinking to do this? I have the idea in my head, I just kind of have to write it out. Also, do we actually use this sync ref thing? Okay, we do for the audio frame. Not entirely sure why. So the pen takes references of T. Why does it need to do that? Why can't it just pass in the T's? Let's just remove this and see what happens. See if I can't just fix that down the line. The main reason I'm doing this all on a branch is so we can just do stuff like that. And have it be okay. So that didn't break anything in this core. Or in this front end. I suspect it'll break stuff in our CLI front end, which is why it seemed to be used there. I'm going to open another terminal here. So now I'm just building the CLI front end here. This should actually, what was I going to say? This should actually show my save files. That's what I was going to say. Because SRAM stuff is implemented in this front end. But yeah, the reason I'm doing all this stuff on a branch is if I want to break things like this, I can just kind of do that aside from master, because I think things will sort of shift around a bit before I decide on like the final code paths here. And I want to actually work on both front ends that affects, and I want to be able to do that and kind of mess things up before I make them better. But this should work. Compile time's not that great. And clap is notoriously slow in particular. So we might be here a couple minutes, but it's actually only because I changed which Rust version I'm using. Right now I'm using GCC rather than MSVC. And that was because I was trying to build a static library of some over some Verilator output. If you guys haven't heard of Verilator, it's really cool. It's a Verilog to C++ simulator compiler, and I was trying to use that to make a static lib that then I would link into Rust so I could write tests against my hardware designs in Rust. Needless to say, that was a really crap experience trying to get all that set up. I did get it working eventually, but it was not clean. I don't have like a nice make file that does that properly, so I've just dropped that idea for now. I'm just going to use C++. Yeah, clap is an arg parser, but I think it uses a lot of macros. Takes a while to build. I'm also building in release, which doesn't help for build times, but you kind of have to do it for an emulator like this because it's not going to be at all fast enough otherwise. I think this is just slightly better than those streams where I would just stare into the Virtual Boy for 5 minutes and tell you guys that it was cool. All right, so now it didn't build, and that's actually what we expected. I'm gonna run that again to get prettier errors. So yes, the idea is that something use syncrefs here, or syncref, particular wave file buffer sync and CPL driver. So all of the stuff use syncref for audio, and I'm really not sure why. Yeah, I'm using Sublime Functor. I should definitely download more RAM. That's totally not the issue either, but I should do that just because of the future. So I think I can just go through here and just fix these. I don't really know why this uses syncref. We're just gonna change this to sync. Ah, because this takes a whole buffer. Right. That's why that was. Right, instead of just passing the whole buffer, we passed a reference to the buffer. That actually makes sense why I did that. But I want to get rid of this syncref thing. So we're going to work around that. This was, again, an attempt to do something. I think we can do this. There was a reason why we couldn't. I don't remember what it was. Sorry, David Francois. No links in my chat. Hey, G Superland. Yeah, I probably should upgrade that at some point. I'll probably do a blanket upgrade once I'm done with more of the Libretro stuff. Yeah, and then Emulator also had one of these. Because there was a reason why we couldn't just do sync with refs like this, and I don't remember what it was. Whoops, that's silly. It may have been that it couldn't infer lifetimes on some of this stuff, but I don't recall that being an issue. Let's find out. Yeah, half the code gone should at least help with the compile times for sure. Because I think like this ideally should work. Maybe it doesn't. We'll find out. Because we need a lifetime parameter. That must have been what it was. Right, so it wants lifetime parameters for the syncs, which I'm not happy about. Because all this really does, if we look at the sync thing here, it just implements a function that will take that value. And the fact is, if we do it this way, we need to actually specify lifetime parameters for that. And I think... Oh, we don't actually need incremental compilation to save us from a lot of this, by the way, because it compiles at the crate level first. So we've actually been safe from that for a while. It's just whenever I switch Rust versions via Rust up, which I do often enough for it to be a problem, then it's an issue. But just to be precise about that. The red exclamation mark, that's Rust Enhanced, it's called. That's where that's coming from. So here's the thing. It expects a lifetime parameter here, even though this is only used as a function argument later. So I can see why we worked around it like this with the sync ref thing. That it's a bit weird that it requires a lifetime parameter for this, which is only going to be a function argument later. I think it does because it just sees a reference somewhere in the type of something we're putting on a struct. So that's definitely why this was annoying. It's not too bad in these other cases, like in CPL driver, for example. There, for us to implement this. I don't suspect it's that bad because we can just do something like this. And I guess that would solve the problem for that case. But the one where it's a member of that struct is a bit odd. In fact, I'll just copy this for buffer sync. We need this here too. And the thing is that we don't want to specify a lifetime parameter here. I'm honestly not sure why this is required. Gotta be honest. Because again, we're not storing this reference anywhere. Which I think is the only reason why this would be required. No, I'm not porting Libretro to Rust. I'm implementing a Libretro API for the emulator that's been written in Rust. That's what's going on here. Libretro is an API specification, so you either implement the API as a core or you implement the API as a host. So that's what's going on here. We're implementing the API as a core, which allows our emulator to be run in Libretro. Or in a Libretro host, I should say. Okay, but anyway, I understand now why we had to do the syncs the way we did them. And I think I'm actually going to put this back and just do the sync ref workaround because, frankly, I'm not really certain why we should need a lifetime parameter on the emulator thing, and I'm not about to just start throwing lifetime parameters around because I think what'll end up happening is I'll end up putting a lifetime parameter on that struct, which isn't actually required. Because we'll basically need two lifetime parameters, one for the struct itself because we need to separate that from the one that's on the reference. And then that's just going to bubble up throughout a lot of code. So I'm going to avoid the problem by reintroducing the sync ref thing that we had. Whoops. It's -p. Not -p. I'll take that back. Take that back. It's probably going to be all the changes that we made, but I only care about these ones. Yes, we don't want to do these ones, for example. So now if we build this, it should work. And that did work. So we're good. In fact, I'm going to commit this, by the way. This was just the stuff we did for 16-bit color. Writing a note to self that I want to support all possible formats, and let the host give us the output buffer. But for now, this makes things a bit more stable. Sorry for my Slack noises. I have a Slack bot that watches that repo, so that's why it goes off when I push stuff. Okay, so what I want to do is I want to get rid of this video frame thing here. I'm okay with this being used for audio frame right now, but what I'm basically thinking is to specialize on the sync. So I want to do something kind of like this. I want the video sync to basically represent the different kinds of output that we could have. So for example, so the annoying thing here is it's gonna kind of stack, but let's say we did anaglyph RGB 0 RGB 1555, something like this. And this is also going to be like anaglyph red electric cyan in particular, right? So we'll have a lot of these, which kind of sucks. We're going to need a lifetime parameter here as well, because this will be something like buffer and mute, and a mute. It could be a vector of, for example, U16s in this case. So I'm thinking the sync will look something like this. And also not vec here, because we should actually just use a slice, because then we can take that from a C pointer. So I'm thinking something like that. And just enumerating a couple of these. So like RGB 565 would be another one that we would take. ARGB 8888, or I think they call it XRGB because it's not used, but it's still in there. Actually, let me look at what they did. So let's, what did they call that pixel format? So many things. Yeah, XRGB. Okay, my phone's blowing up. Hold on. Yeah, I'll get to that in a minute. Okay. Yeah. So the 0 in RGB here, that's just, they call it 0 RGB 1555. I think this should rather be called X in the sense that this is also XRGB. The idea is just something to name that other component for this one bit here that basically is ignored. But this way the 1555 all adds up to 16 is why they do that. In this case, 565 is also 16. 8888 is, excuse me, this is U32. So, but yeah, so the annoying part here is that this does add up like this. Whereas I think what Dark Second pointed out as well is that we could do something like this, where instead we do like the format here, or this is the pixel format in particular, and that determines what our buffer is going to be, and then we also have, like, for example, a pixel format, so we can do pub enum video format. Or now the downside of this is that there is still going to be some coupling in terms of the size of these buffers and what the format is. For example, different, like, if there's a side-by-side format, then these are actually expected to be a different size and stride than this. But I think this still makes sense. So this would be anaglyph format, and we should get something like, or stereo format. Anaglyph red, electric cyan, for example. NGT, yeah, I would totally recommend the official book. I'm not sure what the best way to learn Rust is at this point, because I learned it a couple years ago, and even then I don't know if I learned it in the best way. It's a really hard question to answer for any language, I think, but I mean, just by doing projects. It sounds like a cop-out answer, but it's the only way I know how, and it's the only way I learned. But then we'll have this, and then something like this. And then perhaps we want to do it like this. Or just video buffer even. Because then this is kind of what we want here. And in fact, since this is always going to be the buffer, we might as well do it like this. There's no real reason to have this be named. Because then what we have is this. We have and then we have the format, which is a stereo format. Oh yeah, and this is a struct now. That's why that complaint. I think this is okay. I think this is okay. The only thing we haven't captured here is whether or not we should gamma correct. And I mean, I could just do this here. The only thing is I don't quite like, because you almost want to specify an additional gamma curve. We could hard code a few particular, because the thing is, when you do gamma correction, you typically want to do it as a table lookup, basically. Oh, I'm not going to add any formats here that Libretro doesn't support. We could do this though. Just specify different values. So in this case, I think I use a 2.2 gamma curve, which is pretty typical. I mean, it'd be nice to store the actual gamma we want, and then the video format has to like store a table of those. So no, as far as I know, Libretro only supports these three formats. Maybe it supports more. We can look at that, but I don't think it does. think these are the only ones. Yeah, they are. 1555, 8888, and 565. It's mostly for convenience on the hosts that this is going to be implemented on, that this exists at all. So I guess it also kind of simplifies it, because if you had just 8-bit color, you would also probably need to specify the palette. Maybe handling that is not very convenient. But I think hard coding available gamma values might be okay. Yeah, I think I'm going to do 2.2. I don't like it, but I think you're right about that. But I'd rather hard code these, because then the implementation can just store that in a table. And I think just supporting these two is actually pretty good. In fact, it's most likely that we only need to be one. I just want to be really explicit about the fact that we're doing that. That's really my concern. But then a video sync, because the main thing that I want to describe here is that the video sync should contain a reference to the buffer that it actually wants the pixel data output into. And then it describes the format that is expected by this. And I think we've captured all of that here. And then when we add more stereo formats, that gets adjusted here, and then the implementation will have to deal with those. And I think that that's fine. Yeah, I can always change it later, just like we're changing it now. So it's not really a problem, but I think I'm fairly happy with this. The main reason I'm just kind of pausing on it now is just because I know I'll have to implement this throughout the stack. So just kind of thinking that this is, whether or not this is correct before I do that. But I think this is good. It may also be that I think sync becomes unused now. And then syncref I might just hard code this to be audio sync, just to take this particular type, which I would be fine with. The other thing I want to do here is, this is stereo format. I think I'm going to call that stereo video format, just because when you hear stereo format, it's easy to think that that's audio. So I think this makes sense. I don't think it needs width and height, because I think that's kind of determined by this. As long as, like, this does not describe that we could do any scaling, and I think that's fine. So I think this is actually enough information that we wouldn't want to also specify width and height. That's why I didn't put that in there. I also don't want to pass around really more data than we have to. Maybe I'll call this pixel buffer. Native frame size is 384 by 224, I think. I need to look that up, actually. Oh, wait. No, I don't. I need to look at it here. 384, 224. By 2, by the way, because there's 2 frame buffers, but that's the size of each frame buffer. And technically in memory, it actually has 256 in the vertical resolution, but only 224 pixels are displayed. So that's what the difference there is. I actually do want to do some, when I do my fuzzing tests against the hardware, I'm going to check if it actually draws in that last area of the screen. Because I'm actually thinking I might be able to use the drawing hardware to do some data preparation for some demo effects using that extra frame buffer area, which I think would be really cool. But I think I'm happy with this because this does capture basically what I wanted to describe. And eventually I want to do this for the audio one as well. So instead of calling append, you fill the buffer. Now I think what's a downside to this approach? So for the first downside, which is what I've thought of already, which is that the emulator now has to know about all these different formats, and I think that's fine. That's it should in order to be fast anyway. That's what this is it's a speed optimization. See you later, 8 little bits. And I'm okay with that. The other thing though is that the way we have it set up currently with the syncs, it would always output like a full frame, and then you would know that happened. So you could take, for example, the most recent one, or if you ran the emulator for a certain period of time and it actually outputs several frames, you could just like keep the last one explicitly, or you could take all of the frames that it output. For example, like if you're recording video, you could take all the frames that it output and made sure you didn't miss any by taking all of them because you had them all in explicit frames. Whereas here we kind of lose those semantics, which is not my favorite thing, but it shouldn't be too bad either because if we're gonna bootstrap this that way, I mean, if we are recording a video, we also still want that to be pretty fast. So, I mean, we might do it in, for example, 256 cycle chunks or something, or 1 frame's worth of cycles all the time. And I don't think we'd actually miss any frames. So we're probably okay with this design in that case too. So yeah, so I don't think we've really lost anything by doing this, except that a lot of the code in the middleware crate will just go away because it won't really serve any purpose anymore. And I think that's fine. In fact, I'll just delete it now because I know that that's going to happen. There's no audio stuff in here either. This is just video stuff. So just get rid of that. And Sublime sucks when you delete stuff, by the way. Let me make sure that that's actually deleted. I think it's actually this theme that really doesn't handle that well, but that actually makes me really annoyed. Oh no, it didn't actually delete it. Try again. I probably have files open in there. Like this one and this one. Okay, now I'm annoyed. Yeah, there we go. This was actually that I had it open, but so now that gets deleted. This no longer uses middleware. The CLI no longer uses middleware. The downside is I just deleted the implementation for that code, but that's fine because I could just look that up on GitHub. Don't care too much about that. And yeah, I still think this goes away. Riasar, thanks for the follow. I really need to set that up, by the way. Set that up so that when people subscribe, that it also gives me a notification. I've been really lazy about that, but I do have a to-do item in my Slack reminders to do that for like a week now. So sorry about that. But yeah, much appreciated. So this is going to break everything. We expect that. Before I fix this, I'm going to go use the restroom, so I'll be right back. And we're back. Yeah, I'd actually also love to pick up that physical Rust book. Although I just ordered a bunch of books. I ordered so much stuff this month, you guys. Like, I came back from Christmas break and was just like, okay, there's certain things I want to order. I want to order a new chair. There's a bunch of books I want to order, like a bunch of stuff. And I just wanted to get it out of the way so it's out of my head. A bunch of posters for my apartment and stuff. So I just ordered a lot of stuff. Which kind of sucks because now I'm down on cash for this month. But here's the nice part: I won't order that stuff later, so like it'll feel like I'm saving a lot of money for the rest of the year. But it's really just that I bought everything now. That's kind of funny. I bought first of all from a friend of mine, because a friend of mine bought a book. It's called Reversing. It's just about reverse engineering stuff, and he bought one, but he actually got sent two of them and ended up paying for two of them. He was going to send one back, and I was just like, dude, I'll buy it from you. And so I just paid him the amount in full, which saved me on shipping and time. So I got that. I got another book called The Black Art of Video Game Console Design. It was from 2005, and apparently it has a bunch of errors in it, but it's supposed to be a really good book in terms of like building up understanding of some basic electronics within the context of building a game console. From 2005, so a lot of it's a bit dated, like it talks about TV video signals and stuff, composite video. But I'm really interested in that stuff anyway, so I'm looking forward to that. There's another one that was called Electronics for Inventors or something. Again, you know, me trying to get more of that basic electronics knowledge, so that's pretty cool. The chair I bought, by the way, it was Secret Labs Omega or something. And I'm pretty sure it got to Norway and then got sent back to the UK. So I got to look into that because it should have been here like a week ago. And the tracking says it's going back to blank. So I guess we'll find out what happens with that. I also shipped out a ton of stuff when I was at my mom's place, like a bunch of old video games and stuff. That's what this pile of stuff on the floor is. It's just a bunch of bubble wrapped video games that I'm not going to unwrap yet until I figure out how I'm going to store them. I've shipped out 5 boxes. So it was my C64 disk drive, which I'm trying to point at. Maybe you can't see it. And so that's 2 of the boxes, and those came, and then the other 3 I'm still waiting on. So it's going to be another box of video games, a box of controllers, and my VIC-20. So I'm really excited to get those. But the thing about tech books, I would love to do a tech book review stream. I got to read more tech books, though. Like the one I talk about all the time is the Computer Architecture Quantitative Approach. Always going to recommend that one because it not only talks about just a lot of details that are kind of hard to find out for, like, if you just search around the internet for like what's in a CPU design and what makes a good CPU design, like those things are hard to find. And it's hard to find information that's relevant when you ask that kind of question. And this book not only presents that information, you know, in a way that's a good order of things to learn, but also it's just a very dense amount of knowledge that's related in one place. It also talks a lot about like how, again, what makes a good design and like how do you measure designs? How do you compare designs against each other using measurable data points, which is the quantitative part. And I really like that. It's a really good book. In terms of the other books I just ordered, I can't review those yet until I've read them. Although I could review the Bunny book, which I read recently. And I guess I've read like Clean Coder. I read a book called Code, which is like it starts with some basic information theory and like Morse code and kind of encodings, and then it gets to different number bases like binary. From there you build, you know, basic circuits with relays, and then it kind of builds up to an 8080 CPU, which is actually really cool. Just kind of goes through that whole process, and then it talks a little bit about software and operating systems, but I pretty much skimmed through that part. I guess I could review SICP as well, Structure and Interpretation of Computer Programs, which is one of my favorite books. It's been a while since I read that. So maybe I could do that stream, actually, now that I'm sitting here thinking about it. Also, Commodore 64 Programmer's Reference Guide. Totally underrated. The Andre Lamoth, that's the same author that did the Black Art of Video Game Console Design, which is one of the reasons I bought it, because I definitely knew the Andre Lamoth name. Hackers is so good. I love that Hackers movie. I don't have a book to recommend learning C, just because I didn't learn that from books, so I can't really recommend that. I'm sure there's great books for doing that. I just don't know any. Is what I'm really trying to say. That's cool. Ion Codes. Yeah, I love that book. By the way, I will show off my C64 disk drive. Because this is a legit 1541. And it's in lovely, lovely shape. I don't know why it does that. When you rub your hands on the vents, it makes a big squeaky noise. But yeah, it's really great. But I really want to show off the VIC-20 that I got, just because it's... I think I've told the story before that I got it for like $20 at a thrift store. There's a bit more to the story than that, but it was an awesome find. It's in flawless shape, so I got it sent out here. According to the tracking, it's been stuck in customs for over a week, so I got to make some phone calls, but... I'm totally going to do like a stream and probably even just like a more professionally produced video just to show it off, because it's so pretty. You know, Mad Moose, I'm going to check. I'm going to check if that's what book this is. Programming graphics. So graphics overview, standard character mode, sprites, and defining a sprite. So we get 131. And by the way, I got this secondhand, and there's like a bunch of stuff in here. Let's see if we can see this. Where like someone underlines stuff in pen and stuff. And stuff. It's not warm, but it's warm in my apartment. So yes, I'm wearing shorts. It's actually, the temperature has been fluctuating a lot here. Which is actually super annoying. Display priorities, other graphics features. Okay, so it wasn't that, I guess. Up here's programming sprites, another look. It's in here. It talks about like where in the viewing area it should go. It's an awesome book. Sprite priorities. Creating a sprite step by step. Oh, look. The person who owned this before me made a spaceship. That's so cool. That just makes me so happy. Guys. There's the hot air balloon. There you go, Mad Moose. I had to check because I knew it would be charming. But the most sexy thing about this book, right in the back, it's going to be hard to show, but this is a fold-out schematic of the machine. It's so cool that there was a time when computers, reference guides for programming a computer came with a schematic of the entire machine. It's so nice. Also, a book that I have sitting here that I still haven't read is Physically Based Rendering. But yeah. Oof, that sounds brutal, Michael McMillan. Yeah, no kidding, Danny Fritz. All right, I better work on this code. I realized when I was in the bathroom that sync will actually still be used. The audio for Libretro currently uses that. We'll change the audio first and then change the other one. Oh, that's awesome, Drew, too. I want to get more of these manuals. Like I got my Amiga came with manuals. My MSX came with manuals, but neither of those had schematics in them. Or the Amiga one might actually. I didn't check. Need to look through that. Yeah, I think that stuff's so cool. By the way, here's another tangent. The guy behind Silicon Prawn, Michael McMaster, I think is his name. He recently decapped the video chip of the Super Nintendo. One of them. There's two video chips in the original design. He decapped one of them. And I'm so tempted to try and reverse engineer that, but I know that would take months. So I can't do it. It's something McMaster. I don't think it's actually Michael McMaster. I think I'm just thinking that because Michael McMillan in the chat, but it's Silicon Prawn. I met the guy once. John McMaster. It's John McMaster. But yeah. Back to the snooker. You guys get that reference? High five. So the biggest thing is we're taking these syncs of video frames, but instead we're going to take a video sync. Now, it may actually be annoying to pass this down with these lifetimes. Maybe it won't be too bad. Nice ion codes. They're very unimpressed. Nice. As in, like, maybe you shouldn't be here. Nice. All right, so 173. I think we can just do this. It might ask us for a lifetime parameter. I hope it doesn't. So now we're going to go into VIP mod. And this one is actually going to be where we're going to have to implement this. Oh, whoops. No, this video sync is all we need. We'll get to that. Then we need video frame in. Oh yeah, this actually gets passed down to a couple places, so we need to do this in a couple more places here. 1086. This is a big file, by the way. But I don't really care. Because it's relatively well organized, at least. And a lot of it is sort of in the same context. Like splitting it up, I don't think would really help. Although some of it might. I'm not sure. I haven't figured out a good way to do it, so I just won't do it. Virtual Boy needs to be changed here. Oh, what did I copy that made it do that? And then, yeah, append here, which is in VIP mod. Here's what we're going to do. First thing we're going to do here, big old to-do. Because I kind of want to fix the top level stuff before doing this. So a lot of stuff kind of changes here. Oh, you're totally right, Danny Fritz. That's exactly what's happening. I always forget that. MSys does that. Whoever came up with any usability things for the Windows terminal. No, they are not. They are not. It's not even a funny joke. And I'm laughing anyway, because shut up. But don't Genius live in a lamp? Okay. Okay. Yeah, because here I did the video callback sync. Right, because I made the new chain of syncs and then took this one out of here and then put it into there. Kind of a backwards way of doing this, but... Here's what we're going to do for now. We're going to keep this as a U16. We're just going to hard code which format we use for now, because that'll be the easiest. And what we should be able to do is something like this. And the buffer no, this does make sense. The buffer is going to be a pixel buffer, and we're going to make it RGB. This one, like that. Then we'll do and finally the format is going to be this format. I have nothing to add to what you guys are saying. You're all correct. I just enjoy it. This is the other thing we're gonna do. I'm just gonna copy this to down here. Because I'm lazy like that. This is gonna be video refresh. I think that's actually okay. How did it infer that? Let me actually look at the code. That should be fine. That should be fine. Right, that's the output. And the input came from frame, which came from nowhere. Oh yeah, we don't need to do this. And then do it like that. No, Mad Moose. I'm fine with all of this discussion until you get to tabs for indentation, spaces for alignment. No. I think I'm also going to inline this because why not? I do not have the best focus today. I'm wondering why this is a problem though. Oh, wait a minute. I know why. That might actually just fix it. Because now we don't have a reference to that. So that would actually probably do it. We don't use middleware anymore. And then, yeah, so... Oh, yeah, there's a private. Whoops. I think we have to make these public in enums. Not my favorite part of this in Rust, actually. This is way better because you can see it basically reallocates the buffer once if it has to, and then just passes that same buffer here. That's pretty cool. That's pretty cool. That's basically what we want. The next step to this is also, again, to use that other code path where we actually get the buffer from the host. But this is basically exactly how I wanted the top level code to look. So I'm thoroughly satisfied with that. Now we need to do this stuff, though. Now, I'm going to remove this unsafe code here for now. We can reintroduce that later if we want to. And this left buffer stuff and right buffer stuff. See, because here it creates those new vectors. And we're not going to do that anymore. Because those are going to be part of the video frame sync. So, particular. Really? Did I do this wrong? Am I just wrong that you have to do this? Oh, yeah, I totally am. I did the wrong ones. That was dumb. Gotta do these ones. That makes more sense in Rust. Okay. and now we have issues here, which is exactly where we should have issues. Yeah, so we have left brightness and right brightness here. And the slow way of doing this is this. The slow way is to match inside this pixel loop. The fast way is to have different loops for this. But we're going to do the slow way because it's still going to be way faster than what we were doing before. And in fact, due to branch prediction, which you guys should all be very familiar with right now due to recent events in the world, this should actually be shit fast because it will always take the same code path. So that should actually be pretty good if we match on these. So that's what we'll do. We'll match. I think first we want to match on the buffer. We'll do buffer like this. I'm going to pull this down so I can see it down below here. This is the stuff that branch prediction is just super good at. If we do, conditionals that basically take the same path every time. So this should be exactly where that shines. So we'll do, and we'll even do this. I think this just works and won't move it. We actually will try to get away with this, even though I think we'll have to move that. I'm also going to do, this also needs to be, for example, RGB 565. I'm just going to implement all these because I don't think they'll be very different. And they should be relatively easy to just do it. Although, here's kind of the annoying part. Or, just trying to think of this. Let's do this. We'll do to-do gamma correction. Yeah, so we can apply gamma correction to the left and right brightness before we do any adjustments. I think that'll be fine. And then it should just be a matter of outputting the pixel data. However, the different elements that we use, for example, is going to be dependent on the format. So even though we didn't elaborate all the different combinations in the data type, we're going to have to elaborate when it's being used here. So, yeah. Well, so it is part of the magic that led to Spectre and stuff, which is why I mentioned that you guys should all be familiar with this right now. But, or yeah, Spectre in particular. But this is fine as long as you have that kind of protection when you switch kernel to user mode. This stuff should still be valid to have a branch predictor like this that's stateful for just user mode. So we should be okay. Yeah, I'll probably just do this for now. And we'll figure out how we want to elaborate this after. Danny Fritz, the point I was trying to make is that this won't actually be, or this will be a very well predicted branch here. What I'll probably do at the end of this, though, is have this do this outside of this loop, but we'll have to see. I need to figure out how I want to do that. But I suspect this will not cause us any problems. It's going to be a branch the first time, and then it'll be predicted after that. Because we're not doing much branching other than that here. We may lose the context because of these, though, but I don't think we'll be. I think we'll be fine. I'll worry about that later. In any case, we're going to match the frame sync dot format. And in this case, it's just going to be the 1. And so here, this gets pretty easy. I actually might have this backwards. I need to look up the code that we used to have. Yeah, this is correct. Although, is it? No, because we do left times left color, right times right color. So I need to look at the usage. Because I'm pretty sure I had this backwards initially, and I'm pretty sure this is why. So I'm going to make sure that I do this right. You see why I didn't do this way initially, though, is because it pushes all these concerns into the emulator, into the video emulator core, rather than up in the bootstrapping, which is kind of where I would have liked that to be. But this will be so much faster that I don't really think we have a choice. Like we really should avoid these unnecessary allocations and memory copies that basically don't give us anything except some prettier code. You can do it as a lambda and just make that generic over that function, and then ideally that should be inlined. So you could actually sort of devirtualize the call. But I'm not going to do that until I know that it's actually going to be faster. And we don't know that until we profile, and we don't know that until it works. So I'm going to make it work first. What was I looking for? This. It's looking correct, but I don't quite trust it. But I'll figure that out in a minute. Okay, so we're going to do red cyan here, and then we can do, because we also have the buffer index here, so we'll do buffer index is, also do this shift right, because it's 555, so shift right 3, and then this can be as U16. And we can do red shift left 10 or cyan shift left 5 or cyan. Right, and it didn't like this, because we'll do as U size. That's fine. Right, and this is what I was kind of worried that it would do. But we can do this. And then these just become mute, mute, mute. and we want ref mute buffer. Or I think we just want ref buffer. I might be wrong about this. Because the buffer is a mutable reference. Oh no, we do need that to be ref mute. These are the details I never remember. The compiler is very helpful. Oh, we don't need this on the match. That's better if we don't need it because it's prettier. Need to actually just read the errors. And then for now, we'll just do this because it's unimplemented, and we can get rid of the warnings. But yeah, that's nice. I'm somewhat pleased with this. Assuming it works. But this is the kind of refactoring that is just going to reduce so much overhead. Right, so now I got some borrowing issues here up at the top. Particularly, this guy needs to be mutable. Or why would this need to be mutable? Oh yeah, just because we're going to mutate this reference here. The whole thing needs to be mutable. Fine. And then here we can't borrow video buffer because it's already being borrowed up here. That's actually fine because what we should be able to do is this. By the way, non-lexical lifetimes would fix that. But I'm still on stable rust. Oh, and we got a panic. Did I implement the wrong one? Yep, I totally did. That's what we wanted. And yeah, here, now we use this buffer and we ignore this one. And it broke. The length is 0, but the index is 0. That's my least favorite error. Why would this length be 0? So I'm assuming it's happening here because this is where our buffer was. And we calculate the amount of pixels, and then we make sure that this buffer is the right size. Oh, this is why. Because before, the way that we were using that buffer was different. And now we index it. Yeah, this is fine. Oh, that works. That's really cool that this works now. And the change wasn't actually that dramatic. Although I'm not doing gamma correct right now. So things actually should be a little brighter. I'm going to do that next before I do a small speed comparison. Yeah, this we don't need. This output size bytes thing. That's kind of cool. Although this should have also used that, but that's fine. Oh, no, no, it shouldn't, because we give it X, Y, and then this is the stride. Right. That's fine. I don't think Libretro does gamma correct for me. It never mentioned that anywhere, at least. It would kind of make sense that it would do that, but as far as I know, it doesn't. Although we could, there's a couple ways we could check that, but actually I'm gonna see if the API mentions that now that you mention it. API doesn't mention it. I wonder if it's in the settings, just to look around here, because if it does, then we totally shouldn't do that. But at the same time, a reason why it might not is for speed again, because if something's already going, like it wouldn't have to do any of that as a post process, which would arguably be preferred on some platforms. Just gonna see if it's mentioned here at all. And if it's not, which it's not, yeah, I don't see it here. So I would assume that it's just not going to take care of that. And I'm guessing that it would be faster to do it in the core, since we're already going to be iterating over this buffer anyway. So, because I think there are cases where you you can actually just specify the buffer to go straight to the video hardware on some platforms. So I think, not my favorite that we have to do it, but I can understand it. Anyway. Just gonna add that note there, and then yeah, we'll do our gamma correct. So I'll gotta look up what our old code did for that. What's that SK this? Not sure what you mean. But yeah, I should just, oh, this will actually end up being faster too, because it only has to gamma correct one component. Or two, rather than three. So that's actually nice. Although it should be roughly the same table lookup anyway, but anyway. So now we have to have a gamma table on here, but that's okay. So we'll do gamma table, and I just did a box of 256 U8s. That's all we need. And then we'll just copy the code that I had for this. Yeah, so we would still want to have gamma correction on our CLI version as well. So we'll at least want to implement it somewhere in our chain. That's absolutely true. But yeah, the way you use this is very easy. Very simple. Very simple. Yeah, left color and right color, and I think, yeah, so we get as U8 here, which makes this super easy. Because now we do this. So we match the gamma correction. If it's gamma correction none, I like to make that explicit when it does nothing. And I'm also not using catch-alls because those can be a code smell. And in a place like this, it definitely is. Because we want the compiler to complain whenever we add a new one instead of just ignoring it silently. So I want to elaborate these explicitly. But now I'm going to just take left color and right color, or left brightness and right brightness, and just gamma correct those. Sick. And so then we should be on par in terms of features. Oh yeah, and then the gamma itself, which is going to be up here. Like that. So we only have one gamma table because we only have one kind of gamma. That's okay. And then the other thing we need to do, mute. And we're good. Yeah, things are a little brighter. Makes everything look a little crisper. Just helps. Sweet. Now I want to do a super unscientific comparison here, by the way. I've done this before. Here's what we're going to do. All these differences should be basically getting rid of middleware. And it should just be color stuff. And it is. So here's what we're going to do. We're going to git stash. And we're going to run this. And I'm going to pull up my task manager. And all I'm going to do, so this is using around, okay, this is actually awesome if it's correct because my average CPU usage definitely went down. It's still pretty high though, because it's around 8.5% right now. When the game's running, when it's actually, you know, doing stuff, not when it's paused. Yeah, so peaking around 9. 8.5 to 9%, a little over 9. Okay, so we can say this average is around 9%, maybe a bit higher. So with that super unscientific measurement, we're gonna get stash pop, and we're gonna hope that this is lower. I suspect it actually will be, but we'll see. Whoops, accidentally moved the window over there. If it's not, I'm not going to be too surprised, but I do suspect that this will help. And anyway, it's something we should do. Let this sit for a minute. You can see, still about 8.5, but it seems to max out there. Yeah, according to this very crude measurement, it seems that we've saved 1 to 2% CPU. And that's about what I expected to see. Oh, that's weird. When it pauses, it goes weird. Wonder why that is. That's new. That's a weird one. I'm also noticing another small difference here. Seems like the frame never gets all the way to black. So it looks like it gets stuck on transitions, so that's a bit weird. Frames in the title bar seems okay. It only updates every like 5 seconds or something. That's weird when we... Is that every time we pause it? It is. Let me do something here. Because here's what I'm willing to bet. I'm willing to bet. Let's do a git stash again. I love git stash. And just build it again. Because here's what I suspect is happening now. I suspect that this actually happened when we changed to 16-bit pixels. And not the change we just made. And I'm guessing it's another thing about Libretro being weird, or RetroArch being weird. So if we pause this, yeah, okay. I'm going to say that's not our fault. Must be doing something strange with the pixel format when it pauses. I don't know what. Also, while we're here, notice we have red on the left and cyan on the right. Just to make sure I still have those right. Just gonna make sure when we see the clouds, it's still the same. And it is. These numbers are oddly consistent. That's a bit weird, but... See, it never gets to black when it fades out like that? That's so strange. That happened before we make this change? I could just take screenshots, but... That would be possible, Michael McMillan. I just don't think it'd be necessary. Testing by hand isn't really that painful. That would be possible, though. At least at this point. Like, if we change any actual logic, we wouldn't want to do that. But I... See, okay, so now the frames are the same. I'm not convinced that they were that different, to be honest. So this goes all the way to black. The other one didn't. In this case, I don't think it would help a lot. I mean, maybe when we're just doing this part, but I don't want to make that right now. So I suspect it might be our gamma correction here. So if we don't gamma correct, whoops. Or wait a second. Because if this is sit without gamma correction, this should go all the way to black, and I think it basically does. Yeah. Then Yeah, see that didn't go quite all the way to black. I suspect it's just the gamma correction. I don't think there's going to be any like timing logic that's wrong here because we didn't change any of that. So that would be very surprising. I imagine just looking at this might just explain it. Yeah, so this does seem to work. Let me actually see, because I wonder. So I did have the same gamma on that. I'm just going to check the old code. Yeah, this does just output as left brightness, right brightness, so this should work. Assuming the order of operations is the same, which it should be. Just gonna drop that a little bit. The table itself should still be the same here. Yeah, the gamma is definitely the same as what we had before. Just weird, because if this were 0, after we do gamma correct, that still should be 0. I mean, I'm not surprised that dark pixels, you know, become lighter. That's what they should do. But I'm surprised this doesn't go all the way to 0. Especially since we're only shifting right here. This is a bit weird. So I'm just gonna look at the order in which I applied these sinks before. I know you guys can't see what I'm doing, but I want to move around, move the windows around. So yeah, so it took the video frame. Whoop, who was that? Sack of Joy, thanks for the follow. Yeah, so it would take the most recent sync and then do gamma adjust and then do the anaglyph stuff, which is exactly what we're doing here. In addition to doing bit depth reduction, which this should be fine for that. That is a bit strange. And it looks like this was the same usage. Looking at middleware, there's the most recent sync, and then it would do gamma adjust, and then it would do anaglyphizer. So the gamma, which again was 2.2, works exactly the same way. It would just separate the color components and then do the gamma table lookup on those exactly like we've done here. And then the anaglyphizer would actually color the pixels, so do a linear scale. which should actually be okay. Although, scaling them by, yeah, even floating point values. This should definitely get to 0. I'm thinking like a very dark number here, for example, 0, should end up being 0 at the end of the gamma table translation. And then 0 shift right 3 is still 0. I mean, it sounds super obvious, but always have to consider those super obvious things when bugs like this happen. So our gamma is the same. Our math is the same. We go over the gamma table, 256 values. I over 256, so this is 0 to 1. And then we raise that to the power of 1 divided by the gamma, which is what we're trying to do. Multiply that by 255 because that's going to be our maximum value again. So we take, yeah, divide and multiply. This is, these would cancel. And then just the gamma curve is going to be applied in the 0 to 1 range, inclusive. And then we even do, just in case, this, however, that should be 255. That bug probably didn't matter, but that's probably been in there this whole time. And then we write out the entry. So this is just a straight lookup table. Or if we have 256 entries initially, then just look one of those up. So then down here, we do our actual gamma adjust. We just take the brightness, which we calculated here, again, is a number from 0 to 255. We calculate the brightnesses. And then we output. I'm not sure what's wrong here. You know, another thing I should check though. Because this was after we changed the output format to be less bits. I'm going to commit this. And I'm going to check out 2 commits ago. And see if it still doesn't quite get to black. Because it may be that it just never did and I never thought about it. And I'm just noticing it now because I see the difference. Which is something that happens to me a lot, so that's why I'm considering this. It's always nice when you think you have a bug and you actually don't. Okay, so it did actually get to black there. I'm going to do a quick print screen here. Actually, yeah, that's fine. Oh, this is Rust. And you're definitely seeing it. I just want to compare this really quick. Well. Ugh. Photoshop is so slow to start up now. And it takes focus from like everything else all the time. I hate starting up Photoshop these days. You can check my borrows. These look the same to me, by the way. I can even pick a couple colors from this. Nothing like good old Photoshop debugging. This is all 8s. And this one. This is more than 8s. So this is actually different. Although I do kind of expect that they would be slightly different. Because the other commit that I had was with the other output format. Oh, what? I hit Q and it did something. I don't know what it did. Oh, it probably didn't do anything. I probably just thought it did. So let me just see this again. Yeah, the flashing pixels at the top left, it totally does do all that. It does that on hardware too. It's hard to see, but it totally does. So the flickering pixels is fine. There's also some fade bugs where it like will flash a previous screen as it fades in and out, and that's also expected. It's just it fades all the way out to black first. It should at least. So I'm suspecting I might have just done things in a different order. The data path looks like it should be the same, but it may not be. So it does still do the shift right 3 and then the same shifts when it does the color conversion. That's what we had in the previous commit at least. That's what's frustrating about this. Because this should essentially be the same. It it could be a precision thing because I know that the anaglyphizer would do, which is the thing that would turn it into a stereo image. Previously, that would actually do a color multiply. But I would still be surprised if that were the issue. Might be, though. Oh, it actually looks like it is. Because it would take red, green, and blue divided by 255, even though they would be scaled. Well, no, because that could be multiplied by up to 255 and then divided by 2. So that actually should be fine. As you ate. And then... Well... So I'm really not sure how this ends up being so different. I'm quite surprised. Micro, thanks for the follow. All right, but here, you know what I think I'm gonna do though, because it's been 2.5 hours. So I think I'm actually gonna go work on this a bit later. I'm gonna amend this commit message. And I'll also mention that pause bug. But I'll go ahead and push this. And we'll either come back to this next week or maybe I'll have an epiphany in the shower tomorrow or something. Anyway, I think this was really valuable. And I think this was a good refactoring. It's something I had in my head for a while. Just knowing that would work. So it's nice to actually see it work, even though there may be a couple bugs here. I don't think it's a game logic bug at all. I think it's just something in the conversion chain. Or in the pixel output pipeline, I should say. But anyway, I'm pretty happy to see this work. So yeah, I'm going to head out. And thanks, guys, for hanging out. And I'll see you next time.